So we've done some simple exploration of our data after pre-processing using n-grams. We can now extend this even further by adding tags to our text. There's two types of tagging that we're going to cover today: parts of speech tagging and named entity recognition. The first method we're going to try is parts of speech tagging. This is where we take each of our tokens and tag them with the associated parts of speech. And by parts of speech, I just mean whether that token is a verb, a noun, an adjective, etc. The second method is named entity recognition. So instead of going through each of the tokens and tagging them, this method searches through our text and pulls out named entities. And by this, I mean things like people, places, organizations, works of art, any kind of named entity that's easily recognizable by most people. These methods of tagging our text can be really useful for exploring our text and understanding what's in there. They can also be used to create additional features for machine learning algorithms, or they can be a really interesting standalone analysis in themselves. Our next two lessons will be taking each of these methods and see how we implement them in Python.
So to do our parts of speech tagging, we're going to be importing the Spacey package and the pandas package. The first step is to load up the Spacey model. So we create a variable named NLP and then use spacey.load, and within the brackets we specify the model we want to use. We'll then load in some text to practice our parts of speech tagging on. For this example, we're going to be using Jane Austen's Emma. We've removed punctuation and lowercase this text, but we have left in the stop words for this. We'll then want to create a Spacey document for our text. This will generate the tokens and their associated parts of speech tags. So we run spacey.doc, and then we use the NLP, and within the brackets we reference our text, our Emma JA. We then want to extract the tokens and the POS tags into a data frame. So we initialize a data frame named POSDF and create a pandas data frame with column names token and POS tag. We then use a for loop to run through each token in our Spacey doc. For each token, it will take the associated parts of speech tag and put this into our POSDF using the append function. Once we've done that, we can then run posdf.head. So you can see here the first 15 words of the text and their associated POS tags. So let's say we want to look at the most common tokens and their associated POS tags in our data frame. We'll create a new data frame called posdf counts and then use the posdf and the group by function. We'll group by the token and the POS tag and then use .size to get the number of rows that fall into that group. We'll then reset our index and give it the name counts. And then we can sort our values by these counts, and when we mark ascending equals false, it will be in descending order. So we're going to get the most common tokens first and their associated POS tags. We can then run posdf counts.head, and within the brackets pop the number 10 to get the 10 most common tokens and their associated tags. So we can see here the most common tokens are of, her, and then we've got their POS tags there and the number of times they occur within our text. Let's say we just want to know how many different words we have under each of the different tags. We can create a new data frame, posdf POS counts, and use the group by function again here. Instead, we'll just be grouping by the POS tags. We'll then be taking each token and counting it. We'll then finally use sort values and ascending equals false to give us the most common POS tags and the number of words that appear within each POS tag. We can then again look at the head of this data frame, and it'll give us the most common POS tags and the number of words that fall into that POS tag. So here we can see that nouns are mostly used within our text 34 times, followed by 22 verbs and 20 adjectives, etc. We can also look at individual tags. So say for example we want to look at the most common nouns that are coming up within our data. We can reference our POS df counts data frame and filter it where the POS tag equals noun. We can then just take the top 10 to get the top 10 nouns that appear within our text. So if we print that out, we can see that the top noun is governess that appears 3 times, followed by friend, mother, daughters, sisters, etc. So we can easily swap this out to look at different POS tags. So here I'm swapping this to look at adjectives, and when we print this out, we can see that the most common adjective is the words more and little, which appear 2 times within our text. So for named entity recognition, we're going to continue using the Spacey package. We're also going to import Displacey to do some nice visuals, and the tokenizer from Spacey. We're also going to be importing the RE package as we're doing a little bit of cleaning in this lesson. As in the last lesson, we start by initializing our Spacey model. We'll name it NLP, and then we use spacey.load and the model that we want to use. The text for the example we're going to be using is just pulled off the Google Wikipedia page, so we're going to name it Google Text, and then I'll print that out and you can have a little bit of a look at that. We'll then create our Spacey document, so we'll use NLP, and then within the brackets we reference our text, our Google Text, and then we can use the for loop, so for each word in our Spacey doc. Here we're using the .ents. We'll print the word, so the token, and then the associated label. This label is going to be the entity label. Once this is printed out, you can see what I mean. So it's picked up the dates, it's picked up people, organisations, percentages, loads of different information has come out of just this small piece of text. We can then use the Displacey render function to create a really nice visual of the different entities within our text. So we use displacey.render, and then the first argument in the brackets is our Spacey document. Then we specify the style, and we specify it's within a Jupyter notebook. Once we run that, we get a really nice visual where our text has been tagged with all the different entities and they're grouped by different colours. This is really nice if you're kind of putting together a presentation or you just like a more visual notebook to work with. It's a really nice function to use. So let's see what happens to our named entity recognition once we clean up this text a little bit. So we'll create our Google Text Clean and then use the RE sub function to remove punctuation. You'll be familiar with this regex from previous lessons. We also append the .lower function to this just to get it all into lowercase and without punctuation in one nice clean line. So once we print this out, you can see how it looks a little different now. The punctuation's gone and it's all in lowercase. So we create a new Spacey document with our clean dataset and we name it spacey.clean. And again, we'll iterate through each word in our Spacey document, this time using the spacey.clean, and we'll print out each word and their associated entity tags. So you can see here a lot less has been picked up because we've removed that punctuation and those capital letters. Again, we can use the Displacey function here to get this into a more visual format. So if you're doing named entity recognition, it's really important to consider at what point in your analysis and your data cleaning you do this kind of work, because if you've cleaned up the text too much because you're doing some machine learning later, it's not going to pick up those entities. So do think about at what point you want to do it. You might want to do it before you do your pre-processing, do a little bit of pre-processing and then test it again. You might need to do some pre-processing to pull out additional entities also. So it's really good to just get familiar with your data, check through it, be aware of what's in there, and then pre-process accordingly and do your analysis at the appropriate point. So let's take what we've learned about parts of speech tagging and named entity recognition and try it out through a practical lesson. We'll start with importing the packages we need. Once we've done that, we can move on to loading our dataset. For this lesson, we'll be using a dataset of BBC News articles. So we can load this in as BBC data and then use pd.readcsv bbcnews.csv. Let's take a look at what this data looks like with bbc data.head. So you can see we have a column for the index, we have the title of the article, the publication of the news article, some links and a description of the article. We can also run bbcdata.info and we can see we have 1,000 entries, so 1,000 rows and no non-null values. It's going to be interesting to see what kinds of parts of speech come out and what named entities can be brought out of these news articles. For now, we're just interested in working with the titles of each of the news articles, so let's pull these out separately. We'll create our titles and then create this as a pandas data frame just of the column titles from our BBC data. Let's check that's worked with titles.head. Perfect, so we can now see we've got a data frame of just one column of the title of the news articles. The next step is to clean up these titles. Because we've covered this in the last lesson, we're just going to quickly run through this, but feel free to pause if you want to take a look at the code again. So we're going to take our titles and convert them into lowercase, remove our stop words, remove any punctuation, tokenize and lemmatize the text. Let's check our processing with titles.head. Great, so you can now see we've got a column called tokens clean lemmatized, which contains the title, but it's been cleaned up, lemmatized and tokenized. Let's unpack the tokens clean lemmatized column into one single list. We'll also do it with the raw text. If you notice when we did our tokenization, we computed tokens on the raw title that hasn't been cleaned up, and we also did it for our clean tokens. So let's create our tokens raw list, which will be from our tokens raw column, and our tokens clean list, from our tokens that have been cleaned and lemmatized. We can then compare how these different methods work across our raw tokens that haven't been cleaned up against our clean tokens. Now we're ready to get started with some parts of speech tagging. The first thing we need to do is initialize the spacey model. So we'll use NLP and then use spacey.load and specify the model we want to use. We then want to create a spacey document from our tokens raw list to see how the parts of speech tagging runs over our raw tokens. We'll use the NLP function and then use the join token to join our tokens together with a space in the middle to make sure it's in the right format to create our spacey document. We then create a new data frame where we want to place our parts of speech tags. So we'll create our POSDF, initialize it as a pandas data frame with the column headings token and POS tag. Let's now create a for loop to take each token and get its associated POS tag. So we run for token in spaceydoc, POSDF equals POS.append, and then we take our token, which is our token.text, and our POS tag, which is token.pos underscore. This will run through each of the tokens in the spacey document, take the text of that token, so just the token itself, and the associated POS tag, and place them into our POSDF. The next thing we'll want to do is create a token frequency count, so counting up the number of times each token appears in the documents and its associated POS tag. So we create POSDF counts, and we create this using POSDF.groupBy, and we're grouping by the token column and the POS tag. We then take the size of this group, so the number of rows in the group, and reset our index. We then sort our values by the counts and set it to ascending equals false. When we print this out, we can see the most commonly occurring tokens. And you can quickly tell that because we've done this on the raw data that hasn't been cleaned up, it's just given us a load of mess really. So there's lots of punctuation and mostly stop words in the most common tokens in this raw data set. However, we can still pull out points of interest by looking at specific POS tags. So let's get started by looking at the most common nouns in our dataset. We'll use POSDF counts and then filter this to where the POS tag equals noun, and we'll just take the top 10. So you can see here our most common nouns in the dataset, the first being war that appears 35 times, followed by the word year at 14 times. Let's do the same with the verbs and see the most common verbs in our data. So here again, you can see words like says, found, win. And if you remember, this is a news data set. It gives you quite a nice overview of what kind of things are being discussed and what kind of topics are coming up in this news data just from this simple analysis. Again, we can do this also looking at adjectives. So we can see the words new, Russian, final are also coming up. Next, we'll move on to named entity recognition. But feel free to also pause this video and try doing some POS tagging on the cleaned up tokens and compare the difference between the two. So to get our NER tags, it's very similar to how we get our POS tags. We're going to initialize a data frame that we want to hold the tokens and their associated NER tags. And we'll call it NERDF. We'll create it as a pandas data frame with the column headings token and NER tag. We'll then run a for loop to get the entity labels for our tokens. So for token in spacydoc.ents, if pd.isNA token.label is false, we'll append to our NERDF the token text, so the token itself, and the token label, which is the NER tag. This is essentially saying that if there is an associated label with this token, append this to our NERDF as a new row. Let's check this has worked by running nerdf.head. Great, so we can see some tokens have been pulled out, such as Liz Trust, UK, Russian, 70 years and 70 seconds. Let's now look to see our most common named entities that appear in the dataset. We'll create our NERDF counts and use the nerdf.groupby. We'll group by the token and the NER tag, take the size, reset the index, and sort the values in descending order. So we can see here that Ukraine was the most commonly occurring named entity in this dataset, followed by England, the UK, and the US. So again, this is starting to give us some insight about what's contained within our data. Let's have a look at the most popular people in our dataset. We want to subset our NERDF counts, where the NER tag equals person, and we'll just take the top 10. So we can see all kinds of names coming up here, and again it's indicative of what the news was covering at the time. In this lesson, we've covered parts of speech tagging and named entity recognition as a way to delve into your data, understand what's in there, and start to do a little bit of analysis. Let's now move on to the next section of the course, where we're looking at the exciting topic of sentiment analysis.